All right, now I'm sure you're eager to get onto the design patterns, but this is the last of the solid design principles. So bear with me, we'll go through this one, and then from then on, we're going to talk about the actual patterns. So the dependency inversion principle, first of all, I have to say it doesn't really connect directly to the idea of dependency injection, because many of you have heard about dependency injection. Dependency inversion is something which is close, but it's not the same thing, and you shouldn't equate one with another. Now, this time around, what I'm going to do is I'm actually going to paste in the definition of the dependency inversion principle for you to read, because it's even less intuitive than some of the other ones we looked at. So the dependency inversion principle is split into two parts. So part A is the idea that high-level modules should not depend on low-level modules, that both should depend on abstractions, and the second idea is that abstractions should not depend on the details, but details should depend on abstractions. Now, I need to explain a couple of things here. So first of all, what is an abstraction? Typically, by abstraction, we mean either an abstract class or an interface. So by abstraction, we mean that you get a signature of something which performs a particular operation, but you don't necessarily work with the concrete implementation. Instead, you're working with an abstraction. That's what an interface or an abstract class actually is. So part B of the dependency inversion principle is fairly simple. It basically means if you can use interfaces and abstract classes instead of concrete classes, because, well, obviously the benefit here is you can substitute one implementation for another without breaking anything. So that's great. We're going to focus on part A. Part A is far more important, and it says that high-level modules should not depend on low-level modules, both should depend on abstractions. Now, you're probably thinking, well, what the hell is a high-level module, and what's a low-level module? What does this all mean? Well, I'm going to do a demo just to show you what exactly I mean. So let's suppose that we want to have some sort of application for modeling relationships between different people, kind of like a family tree kind of application. So we might have, for example, an enumeration for the kind of relationship that can exist between two different people. So I'm going to have an enum called relationship, which is going to have things like parent, child, and sibling, and you can think of other ones as well. Now, in addition, we're going to have a class for representing a person. So class for representing a person, here I'll just have a public string name, and I'll have a constructor for initializing the name. Apart from that, I'm not going to put anything else in person. Now, typically, if you were doing a real-life kind of family tree application, you would have date of birth or place of birth or nationality or lots of other things in here. We're going to just focus on people and their names. So now what you want to do is you want to somehow model the relationships between different people, and for that, we may as well make a class. We're going to have a class called relationship. Relationships. So here what I'm going to do is I'm going to just keep a list of all the relationships between different people, and what I'm going to be using is I'm going to be using Java tuples. So I'm going to be using a class called triplet, which is a tuple with 3 elements. So for storing the relations, I'm going to have a private list of triplets, and each of the triplets is going to have the person, the relationship, and the other person. So this is going to be called relations. Okay, and I'm just going to initialize it with a new array list. There we go. Okay, so we have this kind of setup, and what we can now do is we can add functionality for actually adding different relationships to the relationships class. So I can have, for example, a method called add parent and child. So this is where you would enlist 2 people in a parent-child relationship. So you take a person called parent and a person child, and you add them into this list. And obviously you would have to add them twice, because the way we've set it up is we can have a relationship of parent, but we can also have a relationship of child. So here I would say relations.add, and I would say let's add a new triplet where we add the parent, the relationship.parent, and child, but we also do it the other way around. So we make a new triplet where we have child, the relationship is a child, and child like so, and then have parent in here. So this allows us to configure the different relationships, and the question is, well, how can we actually do something with it? How can we perform some sort of research on the people and their children, for example? Well, for that, we're going to make a new class. I'm going to make a new class called research. Now I'm going to do all the research in the constructor, so I'm not going to have any additional methods, just the constructor. And obviously what we're going to need to do right now is we're going to need to depend on the relationship. So if you perform some sort of research on a relationship between different people, you need to take relationships as a constructor argument here, because you need some data from it. And this relates to the dependency inversion principle, which states that high-level modules should not depend on low-level modules. I'll explain what's going on in a moment, but for now, let's just say that we want to perform this kind of research. Now, the problem is that relations up here is a private member, which means that you need a getter for it in order to make it available. So let's actually just generate a getter like this one, for example, get relations, and now we can start working with it. So here in my research module, what I would do is I would say relationships dot get relations. So call.get relations, make a variable out of it called relations. That's an OK variable. And then I can take relations and I can perform my research. So for example, let's suppose I want to find all the children of a person whose name is John. So I would say relations.stream. And then I would say filter. So I need to find all the people whose name is John and they are a parent of somebody. So if we check X, we look for X dot get value 0 dot name dot equals John. So that's one criterion, but we also need this to be a parent. So and X dot get value 1 is equal to relationship dot parent. So we need somebody called John who also happens to be a parent. And when we get all of these entries, then for each of the entries, what we do is, well, we may as well do some sort of printout. So we have a child here, and we say system.how.println. So we're just going to print it to the console here. And I'm going to say John has a child called. And then, well, in actual fact, this child thing is not really a child. It's a tuple. It's the whole entry, the whole triplet. So here I'm going to say ch.getValue2, like so, .name. And that gets us the name of the child in this particular case. So this is something that we can actually run. We can build a demo and run this. So I'm going to make a class called demo here. Public static void main, and here what I would do is, first of all, I have to set up the scenario. So I'm going to have a new person called John, capital J. Let's make a variable out of that. So that's going to be the parent, and then I'll make a new person. Let's suppose John has 2 children, so I'm going to have a new person. This one's going to be called Chris. So variable that I'm going to call child1. And then I'll just duplicate this, and this one, I'll put the name Matt in here, and that's going to be child2. So now we set up the relationships module. Relationships equals new relationships. Like so. We add the parent-child relationship. So we say relationships.add parent and child. We say parent, comma, child1, and we do the same for child2 as well. And we are good to go. So now we can perform the research. New research, relationships. There we go. So this is something we can actually run. And because we can run this, well, let's actually run this and see what we get. Okay, so as you can see, everything works just fine. We get the output we expect, which is that John has a child called Chris, John has a child called Matt. So everything seems to be working, and you're probably wondering, well, what is the problem with this code? Well, in actual fact, there is a fairly major problem. We are exposing an internal storage implementation of relations as a public getter for everyone to access. And this is a good time for us to discuss high-level modules and low-level modules. So in our example, relationships is a low-level module. It's low-level because it's related to data storage. It simply provides a list, or it keeps a list, and it gives us some sort of access to that list. So it's a low-level implementation. It doesn't have any business logic, as you would say, of its own. It simply allows you to manipulate the list, and that is its single responsibility. So here we encounter the single responsibility principle, which is the relationships class. Single responsibility is to allow manipulations of the list that we have here. Now, on the other hand, research is a high-level module. High level, because it allows us to perform some sort of operations on those low-level constructs, and so it is a kind of higher to the end user, so to speak, because the end user doesn't really care about the storage implementation. They care about the actual research. They want the results. They want to know what are the where is John and who John's children are. That's what the users care about. So this is a high-level module. Now remember, the dependency inversion principle states that high-level modules should not depend on low-level modules. But unfortunately, that's exactly what we have in this constructor. We have a constructor which takes a low-level module as a dependency. And this is bad. This is violating the dependency inversion principle. So you're probably wondering, well, okay, how can we actually fix it? Now, remember, the second hint of the dependency inversion principle was that you should depend on abstractions instead. So how would you depend on an abstraction? Well, first of all, you have to introduce an abstraction. So I'm going to go up here and I'm going to introduce an abstraction. It's going to be an interface called a relationship browser. So a relationship browser is going to have just a single method, which is going to find all the children of a particular person. So it's going to return a list of person, and it's going to be called find all children of some particular name. So you provide the name of whoever you're interested in, and it gives you all their children, assuming they have any children. Otherwise, you just get an empty list. So this is the abstraction that you would be expected to implement on the low-level module, for example. So let's jump into relationships, and let's implement this in relationships. So right inside relationships, I'm going to go implements, relationship browser. And this is precisely the location where you'd actually be expected to implement the method and perform the search. So the search doesn't happen in the high-level module. The search, the kind of core functionality, is happening in a low-level module. Why? Why are we doing this? Well, the reason is that let's suppose you decide to change the implementation from a list to something else. With a direct dependency on a low-level module, you cannot do this because remember, we're getting relations as a list here. So if you change it from a list to something else, like an array, for example, you're in trouble because you're going to have to rewrite lots and lots of code. You're not going to be able to do stream, or you'll have to do it differently, and this is a problem. So instead, we're doing everything in a low-level module. This is where you would actually go about finding all the children of a particular person. So you would actually go ahead and perform the search. Let me actually stick the code in here. So it's fairly obvious stuff, except that here I've been using a couple of additional constructs as well, like objects and collectors and whatnot, but it doesn't really matter here. I'm just going to leave it as is. Everything here is correct. So we have this very similar idea of just finding all the children of a particular person's name and returning that. So now the upside is that back in the research module, we no longer have to break the dependency inversion principle, because instead of depending on a low-level module directly, we're going to depend on an abstraction. We're going to have a research which is going to depend on relationship browser. That's the interface that we defined. So this is where you would actually use the browser to find the children. So you say browser dot find all children of John. Let's make a variable out of it. Let's call it children. And then you can just iterate the children. So you can say for person child in children, let's print it out. System.out.println. So we're going to print out John has a child called, and once again we can just do child.name, and that's pretty much it. So you notice we have simplified the code somewhat, and we've also added additional flexibility, because now if you want to change your code, if you want to stop using a list of triplets, and maybe you think it's clumsy because, well, getting data from unnamed tuples is particularly ugly. Maybe you want to change it to something else. Maybe you want it strongly typed. Maybe you want each of the person relationship, person constructs to appear as part of a separate class that you define. You can do it. And previously, when we were violating the dependency inversion principle, you couldn't even do it because you were so strongly dependent on that implementation detail in your high-level modules. And you shouldn't depend on implementation details. You should depend on abstractions like the browser here. So the interesting thing about this setup is if we go back into our main method, we don't really have to change anything. So what I mean is I can take this implementation, this constructor, and I can just comment it out. We're going to start using the new one instead, and I don't have to change a single line of code inside the main method. Everything continues to work as before, because remember, the relationships construct that we've made actually implements the relationship browser interface. So when you call new research, you're now calling this constructor, and that's exactly what we wanted in the first place. So let's actually run this just to see that we're still getting the right results. As you can see, we're getting exactly the same output as before, so everything is great and we're no longer violating the dependency inversion principle.